Hey, so today we're going to look at limiting reagent problems or limiting reactant problems. Oftentimes in chemistry when we have reactants and products, we'll run out of one of our reactants first. In all of our questions up until this point, we've been talking about one reactant. We'll be given one reactant, and another one it'll say you have excess of this one, which basically means that you're not going to run out of it. We only need to focus on the one reactant that we were given information about. An example of this is if I light a match in the classroom, I'm not worried about the match burning up all the oxygen in the air and all of us suffocating because there's lots of oxygen, but there's very little match, a little bit of wood to burn. So I know that nobody freaks out because we know that that little match is not going to use up all of the oxygen when it's burning. So we have an excess reactant, which is the oxygen, and a limiting reactant. We see this all the time in real life. So if you're talking about making brownies, for example, like you see, it takes, if we have 2 boxes of mix and 12 eggs, well, to make a couple batches of brownies, we only need a couple eggs per box, so we're going to have a bunch of eggs left over. So the limiting reactant in making brownies here would have been the brownie mix itself, because you're going to run out of that before you run out of eggs. So whenever we're looking at a system or a reaction where we have an amount of each reactant, we got to figure out which reactant is going to get used up, because that ultimately will stop the reaction, just like the brownie mix stopped the making of brownies. We ran out of it, so we can't make any more brownies. That's it. It's done. So a limiting reactant is, or a reagent is another way to call it, another word for it, is a reactant that limits the final yield of products because it gets used up before everything else does. It's the reactant that gets used up first. An example could be making burgers. So if this is the recipe for a burger, it takes 1 patty, 1 slice of cheese, a couple tomatoes, and a bun. If you have the ingredients that are in the picture, the reactants, you're going to have some excess because the limiting thing here would be the patties, because you only have 3 of those. You have some extra cheese, you have an extra tomato, you have an extra bun, so you're only going to get 3 actual burgers. And in chemistry, like in real life, you could just make a cheese and tomato sandwich, I guess, but in chemistry, the reaction would stop at that point because the molecules have to combine to create those products. And if there's any leftovers, they just stay there as whatever they were. So just like the bun and the tomato and the cheese in this example. So most chemical reactions will proceed until that limiting reactant is consumed. And once it's consumed, the reaction will stop. Everything else, all the other reactants that we have extra of, are called excess. Extra meaning excess. So here we go. Here's another example. My favorite analogy for chemistry, because it's a simple reaction, is making grilled cheese sandwiches. Here's the recipe for making a grilled cheese sandwich. You have 2 slices of bread and 1 Kraft single. I'm still waiting for my sponsorship dollars from Kraft, but regardless, you're going to use those reactants to make 1 grilled cheese sandwich. You add a little bit of heat, so this would be an endothermic process, according to our lesson from before, and this is our recipe. So if we want to make that cheese sandwich, there's our recipe. 2 bread, 1 cheese makes 1 sandwich. Notice we're not talking about the masses of bread and cheese because they weigh different amounts. It's not the masses of cheese and bread that will dictate the sandwiches. I mean, to a point it does, but it's how many slices you have. So in chemistry, when we're dealing with reactions, our moles are kind of like our slices. So if we have 8 cheese slices and 10 slices of bread, let's figure out how many sandwiches we could make. Now, what do you think would be limiting here? Well, if I wanted to make sandwiches from the cheese slices, I have 8. It only takes 1 to make a sandwich, so I should get 8 sandwiches from the cheese slices. But the slices of bread, because I need 2 to make every sandwich, I'm only going to get to make 5 sandwiches from that. So in other words, bread is going to be my limiting reagent. So you could check it out. There's a simulation that I've asked you guys to do from the FET website. You can check that out and play around with that, so you can mess around with some limiting reagents. So here's what it would look like if we did so. You're going to get your 5 sandwiches, but you're going to have some cheese left over. So cheese would be our excess, and the bread is what we call limiting. And so I don't worry about how much cheese I have because I know I have extra. It's the bread that determines how many sandwiches we can make. So which reactant is limiting? Obviously the bread. We have enough cheese for 8 sandwiches, but only enough bread for 5. How much excess reactant? Well, we're left with 3 slices of cheese. So to do limiting reagent problems, that's our first issue, is we have to figure out which reactant is going to limit or cause the production of a specific amount of product. So in order to solve these problems, I've laid out the steps again, and we'll go through them one at a time. First things first, we always have to have a balanced reaction, just like every other stoichiometry question we've done. Whatever you're given, we have to change it to moles. We can't work in anything other than moles because the ratios are dealing with mole ratios, the amounts of things. Just like the cheese and bread, if I give you a mass of cheese, well, you'd have to figure out how many slices you could make from that. So we got to know the individual number of things rather than the mass or the volume of those things. We're going to change those quantities to moles then. Once we do that, we're going to look at the moles of each reactant and figure out which thing we're going to run out of first. That's the most important part. And then once we've got that, then we can just pretend that the other thing is, well, not pretend. We can just say the other reactant is excess, and we just work with the limiting reactant from there on out. That's what I mean here. We're going to use the moles of the limiting reactant to figure out the moles of whatever we're looking for, whatever product you're being asked to find, and then we convert those moles to the whatever units the question wanted you to find. So here are some examples of a limiting reagent problem. Now there's a few different ways to solve this. Some people will just solve out both reactants to figure out how much product they will make, and whichever one's less, that's your limiting and that's your answer. I feel like my method has a deeper understanding of what limiting reagents mean, and also it shaves off a step or so. But I mean, if you find another way to do this that makes sense, go for it. But here's how I would attack these problems. The first thing we're going to do is write our balanced reactions. So we're reacting ammonia gas and HCl. So I'm going to write my reactants. So ammonia is NH3, and HCl, they gave me that, hydrochloric acid. And we're making ammonium chloride. So ammonium chloride, ammonium, remember, is NH4 with a plus, and Cl is a 1 minus. So we have NH4Cl. So I've chosen a nice, easy reaction. The ratios are all 1 to 1 here. Now, in the question, and how we identify this as a limiting reagent question, is that we have 1 gram of ammonia mixed with 1 gram of HCl. So we've been given the amounts of both reactants. So our first step is to figure out which one of those is going to get used up. To do that, we have to get into moles. We got to talk about the number of things, not the mass of those things, because ammonia and hydrochloric acid both have very different masses. So I'm going to write out my 1 gram of ammonia. 1 gram of NH3, and I also have 1 gram of HCl. I'm going to convert both of these to moles. So we know that 1 mole of ammonia weighs 17.03 grams, and we know that 1 mole of HCl weighs 36.51. So when I solve this out, I get 0.06 moles of ammonia and 0.03 moles of HCl. Now from here I can actually already see which reactant is limiting, and the reason for that is I know from the question or from the reaction that to react perfectly I need 1 NH3 and 1 HCl, or 1 mole of NH3 and 1 mole of HCl. So in other words, we have to have equal amounts to use them all up. We're not going to get to use them all up because we don't have equal amounts. So in this case, it happens to be the one that you have less of that's going to be limiting. Now, it doesn't always happen that way because of the ratios. Just because you have less of something doesn't mean you're going to run out of it. If you need more of the reactant that you have lots of, you're going to use it up faster. So the way I do these questions is I'll look at one of the reactants and I'll use that reactant to figure out how much of the other one I need. So I always just pick the first one. So I'm going to pick this one here. I'm going to say, okay, if I have this many moles of NH3, let's find out how many moles of HCl we need to use that all up. So 1 mole of HCl is needed every time we use 1 mole of NH3. So that gives us 0.06 moles of HCl. So if we go back here, this is what we actually have to work with, and this is what we would need to use up that NH3. So if I look back to what I have only 0.03 moles of HCl, and I need 0.06. I don't have enough to use up all of my ammonia. So that means that this is the limiting reagent. I'll just put L dot R for limiting reagent. This is the number that we use to solve the question. If we go back to the question now, we could say that ammonia is excess. So what that does is it really gets rid of this 1 gram of ammonia. We can actually just say that it's excess ammonia, and we're reacting with 1 gram of HCl. So it's just the HCl we need to use to solve the question. So I'm going to take the number from here, the amount we have, not the amount we need. We can only work with what we have. And I have 0.03 moles of HCl. That's going to determine how much ammonium chloride I can make. So we're going to just now continue on like we'd normally do with stoichiometry. We've done grams to moles, and now we're going to do our mole ratio. So my mole ratio is between HCl now and NH4Cl, because I want to go from here to here. So let's find NH4Cl. Well, 1 mole of NH4Cl is made every time we use 1 mole of HCl. So 0.03 times 1 divided by 1, still 0.03. And that's moles of NH4Cl. Now that we have that, we can actually take it the next step and find the mass, which is what the question was asking for. So we'll take that 0.03 moles, and we're going to times it by the grams per mole of that compound, which is 53.54 grams per 1 mole. So I get 1.6 grams of NH4Cl, and there's your final answer. So balance reaction, convert to moles, find the limiting reagent, use the limiting reagent to solve the rest of the question. Let's do another one. So we're going to burn some calcium metal and oxygen, and we're making calcium oxide. So I'm going to set up my reaction. Calcium would just be Ca. Oxygen is O2, and it's making calcium oxide. Since Ca is a 2 plus, O is a 2 minus, CaO. Reaction's not balanced. I have 2 oxygens on the reactant side, so I need a 2 there, which means now I need a 2 here. So I have my balanced reaction. Now, again, the reason why this is a limiting reagent problem is we have the mass of both reactants. We don't know which reactant's going to get used up first. So I'll convert them both to moles first, 0.48 grams of calcium and 0.32 grams of oxygen, and we're going to change these to moles. So 1 mole of calcium is 40.1 grams, and 1 mole of oxygen is not 16, 32 grams. So now, divide these out, round it off a little bit, I get 0.01 moles of calcium, and I get 0.01 moles of oxygen. I'm rounding a little bit here, but just to keep the numbers nice and neat so that we can kind of see how this should work out. Again, this is the amount that we have to work with. So one of these 2 numbers is the number we have to use to solve the question, but we got to figure out which one. Now again, you can just use a little bit of logic here to figure it out, but not always will the numbers be so nice and so the ratio is so easy. But if we look at the reaction, for every 1 oxygen, I need 2 calciums. Well, I have 0.01 oxygen, so to use it up, I should probably have 0.02 calciums. I can probably already see that the calciums are going to get used up first. But if you can't, we just choose one. And so I'd like you to get into this process so that when the numbers aren't so nice, it's a little bit easier to figure out your limiting reagent. So I'm going to use the calcium. Again, I always just pick the first one. I'm going to figure out how much oxygen I need to use up all of this calcium. So I'm going to times by 1 mole of oxygen for every 2 moles of calcium. That's our ratio from the reaction. So to use up all the calcium, to use up all the calcium, I'm going to need 0.005 moles of oxygen. This is what we need. So I always go back and I compare what we need to what we have. Well, I need 0.005, I have 0.01, I have more than I need. So if I have more than I need, we can call that extra or excess, which means that this is my limiting reagent. Again, you could think of it as now what we've done is we've figured out which number we have to use in the question. Since calcium is my limiting, I can just say and get rid of this 0.32 and say I have excess oxygen. So now I'm going to use the calcium to solve for the question, solve for the answer. So I take my 0.01 moles of calcium, and I'm going to go from calcium to calcium oxide. Nice, neat ratio, 2 moles of CaO for every 2 moles of Ca, so 0.01 moles of CaO. And then our next step is to change the moles to grams, so grams on top, moles on the bottom. It's 56.1 grams per 1 mole, and we get 0.561 grams of CaO. And there's your final answer. So I've got a couple try these ones for you guys. I believe the answers are already posted online on the website. So I'm going to put the worked out solutions. So I'm going to put the final answers up. You guys can try them and see how you do with it. Just follow the process that I laid out on the last 2 questions and see if you end up with the same answer. In the first question, you should end up with Cl2 being your limiting reagent, and then you should end up with an answer of 0.702 grams of NaCl. In the second question, you should end up with H3PO4 being your limiting reagent, and your final answer should be 13.8 liters of carbon dioxide. Shoot me a message through Edmodo if you need any other help with that.